My screen is visible or not? Let me know. Is my screen visible?
Yes,
Hello.
sir. Yes, sir.
Okay, thank you. Thank you. Okay, so today we gonna start the design of silos. Silos basically are of circular shape, so you don't have a design of rectangular silos. Basically, silos are of circular shape. Okay, so in case of bunkers, you will get rectangular bunkers, circular bunkers. But when you come to silos, when you come to design of silos, so silos are basically of circular shape. So you are required to design the circular silos. So already we have discussed the difference between the bunkers and the silos. The bunkers are the small bins, small storage device, storage equipments, and the silos are the larger storage equipments. So this is the basic difference between bunkers and the silos. We have also seen the technical difference between the bunkers and the silos. We have drawn one angle, that line that is called as line of rupture. When line of rupture meets the horizontal surface, then it will be called as bunkers. When the line of rupture with some angle with respect to the horizontal, when it meets the opposite wall, then it will be termed as silos. Okay, so we'll start the design of silos. Design of circular silos. Design of circular silos. Okay, so here directly we will do the problem, do the design problem. In the problem statement, internal diameter is given, internal diameter, which is 6 meter, height of cylindrical portion, height of cylindrical portion equal to 20 meter. So you see, you have the sketch of the silos like this. So it consists of a cylindrical portion and hopper bottom. Okay. So there may or may not be surcharge. Surcharge, sometimes surcharge will not be there. Okay. So if surcharge is given, then consider. If it is not given, then don't consider. So height of the cylindrical portion they have given as 20 meter. This is the cylindrical portion that we have. Then below the cylindrical portion, we have the hopper bottom. Then density of the material is given. Density of the wheat is given here. Density of the wheat, density of the wheat that is to be stored in the silos, which is 8 kilonewton per meter cube. Okay, and coefficient of friction is given. See, since silos is having larger length, the depth of the silos is more than the depth of bunkers. So there will be the consideration of the frictional force because length is higher as compared to the length of the bunker. हेलो जी मैडम.
Yes.
जी वो जो आप कह रहे थे ना मार्क्स जहाँ पे मिलते हैं वो वाला लिंक मुझे मिल नहीं रहा है। मैंने एक सेव तो किया है बट वो वाला लिंक है जिसमें हम लिंक पेस्ट करते हैं। वो आप दे सकते हैं क्या मुझे? मुझे समझ में आएगा
मैं
कैसे
अभी
करना
अभी
है।
क्लास ले रहा हूँ. मैं क्लास लेने के बाद मैं आपसे, हाँ, आपसे शेयर करता हूँ.
यस
ठीक है. Okay, so density of the wheat is given 8 kilonewton per meter cube. Coefficient of friction is given because frictional force is prevalent in case of silos. Coefficient of friction Coefficient of friction is given. Friction between the wall and the material. Between wall and material is given. Mu equal to, that is it is denoted by mu dash, that is 6.444. Okay. Pressure ratio is also given. Sometimes they will not give you pressure ratio. What is pressure ratio? I will tell you. First, let me write pressure ratio. Pressure ratio, it is denoted by eta, equal to pH, horizontal pressure, divided by PV, vertical pressure, equal to zero point 0.4. So since it is given in the problem here, we are taking. If it is not given, you can assume zero point 0.4, zero point 0.5, zero point 0.3. You can assume any value, okay, between zero point 0.3 and 0.5, or you can take zero point 0.4. No issue in that. Angle of repose is given. Angle of repose, phi equal to 25 degrees. And they're asking us to use M20 grade concrete and Fe415 steel. And one more thing is mentioned here, which theory we need to use. You see, in case of bunkers, we have used Rankine's theory to determine the horizontal pressure. Here we have two theories by which we can determine the horizontal pressure. One is known as Jansen's theory and other is known as Airy's theory. So most of the time, you have to calculate the horizontal pressure by using Jansen's theory in case of silos. Okay, there are two theories basically I'm talking about. There are two theories by which you can find the horizontal pressure in the silos, in the design of silos, but most of the time they will ask you to use Jansen's theory. Okay, Jansen's theory, use Jansen's theory for silo design. For silo design. One more theory is there, A theory, Airy's theory. Okay, so in our topic, we will discuss Jansen's theory because this is what is asked most of the time. Okay. Now, the pressure ratio eta, which is equal to PH divided by P, can also be written in terms of trigonometrical function 1 minus sine phi divided by 1 plus sine phi equal to sine phi equal to 0.4. Okay. And uh, in the Jansen's formula, I will just tell you what is Jansen's formula. Step one in the design problem, calculation of pressure using Jansen's formula, Jansen's theory. Jansen's theory. So here we have horizontal pressure Ph equal to gamma into R divided by mu dash. What is mu dash? Coefficient friction. Gamma is density of the material. R is hydraulic mean depth. I will tell you how to find hydraulic mean depth. Bracket 1 minus E raised to minus mu dash mu dash into eta, that is pressure ratio, into H, height of the silos, divided by R. hydraulic mean depth. Okay, so this is the Jansen's formula that we need to use to find the horizontal pressure. So first understand what is there in the formula. Gamma is the density, R is the hydraulic mean depth, mu dash is the coefficient of friction, and here h is the height of the cylindrical portion of the silos. If you are calculating horizontal pressure in case of hopper bottom, then height will increase. Okay. So when you're finding the when you're designing the side wall, then this height is the height of the cylindrical portion. Okay. So we will see how to find this hydraulic mean depth. R. Hydraulic mean depth. Hydraulic depth is equal to area of the section divided by perimeter of the section, perimeter of the circle. Okay. So area of the circle, this is circular silos. So area will be pi by 4 into d square. And perimeter, the formula of the perimeter. Perimeter means circumferential distance of the circle. It is 2 pi r. If you are using diameter, then it will be pi d. Okay. So equal to what you have here, it is d by 4. D by 4. And what is d? Diameter of the circle, it is given problem, that is 6 meter, 6 by 4, and the hydraulic mean depth is coming as 1.5. Okay. So R, we got R, and we need to find the depth. Okay. pH, horizontal pressure. Gamma is 8. Hydraulic mean depth is 1.5. Mu is given in the problem, that is 0.444. 1 minus E, mu is minus 0.444 into pressure ratio is 0.4 into height. I'll simply write H as of now, divided by 1.5, that is R. So this is what you get. Now, for different depth of the cylindrical portion, you have different value of pH. For zero depth, the pH is 0. You just have to substitute the value of H. Okay. So for 5 meter distance, the pressure is 12.07. You just have to substitute here the value of H. 5 meter, H equal to 5 meter, H equal to 10 meter. You're finding the pressure at 5 meter interval. At 10 meter, the pH is 18.275. At 15 meter interval, the pH is 22.45. At 20 meter is the height of the cylindrical portion. That is the maximum depth of the cylindrical portion. At 20 meter, the pressure is 24.49. So what we have to do here, we have to select the maximum pressure. Maximum pressure is at the maximum depth of the cylindrical portion. So pH, the maximum horizontal pressure, is equal to 24.50 kilonewton per meter square. Okay. Now you see the silos is circular, and circular silos or circular side wall will be subjected to hook tension. Already we have seen when we have designed the circular bunker, it is subjected to hook tension. I know the formula of hook tension. Okay. Okay, we got the pH. Now we will do step number two. Step number two. Step number two is design of vertical wall. Design of vertical wall or side wall, you can call. See this that you have in the silos. This is your vertical wall and this is the hopper bottom. Okay. So what we are doing now, we are designing the vertical wall or the side wall. design of vertical wall. So I told you vertical wall will be subjected to hook tension. Okay. So hook tension is given by hook tension equal to PhD divided by 2. Okay. So pH, just now we have calculated, that is 24.50 into diameter of the circular section. The internal diameter is 6 meters divided by 2, and it is coming as 76.2 kilonewton. Okay. From the hook tension, we find the factored hook tension, TU, 1.5 into factored. वालेकुम सलाम, बोलिए सर। सर क्लास ले रहा हूँ एमई का क्लास ले रहा हूँ। अभी 1-1.5 घंटा चलेगा, 1-1.5 घंटा। 1.5 into 76.2, this is coming as 114.3 kilonewton. Okay, so this is the factored hook tension that we have gotten, and we can now find the reinforcement. Once we have gotten the factored load, from the factored load, we can find the area of reinforcement. Okay. To find the area of reinforcement, you also have to assume the thickness of the side wall, and you can assume between 150 mm to 200 mm. Okay, so we will assume the thickness of the side wall. Let thickness of the wall, let thickness of the wall be equal to 150 mm. Okay, so once you have assumed the thickness, you can find the minimum reinforcement, AST minimum. And the minimum reinforcement in case of silos also, it is just like a slab. So the minimum reinforcement of the slab is applicable to the minimum reinforcement of the silos. So IS code 456-2000 has given the provision for calculation of the minimum reinforcement of slab, reinforcement in the slab, that is 0.12% of B into capital D for HYSD bar. B, what is B? B will be 1000, and D is just of the wall, that is 150 mm, and this is coming as 180 mm square. Okay, now find the AST with respect to the hook tension, the factored hook tension, that is TU divided by 0.87 Fy. Okay, so TU is 114.3 into 10 to the power 3. We need to take in Newton here. 0.87 into 415. Okay, we are using HYSD bar. So this is coming as 316.58 mm square, which is greater than AST minimum. So whatever AST we have gotten, we can take that, okay, because that is greater than AST minimum. So we can assume any diameter of the bar. I will assume 8 mm diameter of the bar, and the spacing formula is area of one bar into thickness, width of the element divided by AST. So area of one bar is pi by 4 into 8 square, and D is width of the element is 1000 mm divided by AST, that is 316.58, and the spacing is coming as 158.77, which is less than maximum spacing. The maximum spacing is 3D or 300 mm. Okay, so we can provide the horizontal reinforcement, provide 8 mm bar at the rate 150 mm center to center as hook tension That is horizontal reinforcement. Horizontal reinforcement. Okay. We also see. We also have to produce the side wall that we have. So in the side wall, the horizontal reinforcement will take care of the tension. We also have to provide the vertical reinforcement in the side wall. And the vertical reinforcement is nothing but the distribution bars. And what is distribution bars? The minimum reinforcement that we provide in the element, in the silos. Okay. So already we have determined what is the minimum reinforcement that is to be there in the silos, in the wall. So AST minimum, that is AST minimum is 180 mm square. Okay, 180 mm square, and we can try 8 mm bar. Okay, and the spacing will be equal to 279.825, which is, you know, less than maximum spacing. So you can write here, provide 8 mm bar at it 270 mm center to center as vertical reinforcement in the side wall. Vertical reinforcement in the side wall. Okay. So up to this point is clear? Design of side wall is clear? Hello.
Yes,
Up to
sir.
this is clear? Design of
Yes,
side wall.
sir.
So we have completed the design of
Yes.
side wall in case of silos. Now the next part is the design of copper bottom. Okay, we will cover that design of copper bottom. That is the next part in our discussion. Step number 3, design of copper bottom. Design of copper bottom. So in the design of copper bottom, again, you need to assume the thickness of the slab, thickness of the sloping slab. So I will assume here thickness provide a sloping slab thickness equal to 150 mm, okay, with 30 mm internal lining. You know, in case of pipes, in case of circular section, in case of cylindrical section, you provide some lines of the concrete material, of any material for that matter, and that lining has some thickness. So here in the design of copper bottom, we are mentioning that thickness of the internal lining. So with 30 mm internal lining, a lining could be of any material. It depends on the usage of the storage devices. You can have lining of the concrete material, RCC material for the it can be of any material for that matter. Okay. So since you're providing lining here, the total thickness will be 180 mm. Okay. So the total thickness will be 180 mm. Okay. Now, at h equal to 20 meter, pH, we got the value of pH in our previous discussion. pH is 24.5 kilonewton per meter square. Okay. And eta is the pressure ratio, that is 0.4. We have seen that. pH by PE, PV equal to 0.4. What is pH? pH is the horizontal pressure and PV is the vertical pressure. So from this ratio, we can find the vertical pressure, that is PV. PV will be equal to 61.25 kilonewton per meter square. Okay, so we PV, that is vertical pressure, and we need to find the loads on the hopper bottom. A, load on hopper bottom. Load on hopper bottom. Now this is your hopper bottom, and this is how vertical pressure will be. Okay, so to find the total load of the vertical pressure, the vertical pressure has to be multiplied with the area of the top of the hopper bottom. So area of the top of the hopper bottom is pi r square. And what is the diameter? The diameter is 6 meter. Okay, and the radius will be 3 meter. So PV into area of the top portion of the hopper bottom, that is pi r square. So this is coming as 61.25 into pi into diameter is 6 meter, radius will be 3 meter, 3 square, and this is coming as 1731.80 kilonewton, which is vertically downward because the load is going downward. Okay. We have the frictional, the load shared by the friction. Total load, total load shared by friction, shared by friction. Okay. See, the friction will resist the load. Since it's resisting the load, it will be in upward direction because with friction, because of the friction between the wall and the material, there will be upward force, and that upward force will resist the downward force. And the formula is given as pi dash into pH into 2 pi r because frictional force is acting at the circumferential distance, circumferential area. Okay, so pi is this is not pi, this is mu, sorry, mu dash, that is 0.444 into pH is 24.5 into 2 pi, this into 3. And this is coming as 205.05 kilonewton, which will be in vertical direction because this is resisting the force. Third, we have, before that, we need to find the volume of the hopper bottom. Volume of hopper bottom, volume of hopper bottom equal to volume of hopper bottom. This is just like a conical shape. So at the bottom, the opening, at the top, you have the circular opening. At the bottom, the opening is 1 meter, diameter is 1 meter. At the top, it is 6 meter. So you are required to find the volume of this element. At the top, the diameter is 6 meter. At the bottom, the diameter is 1 meter. Okay. So 1 by 3 pi by 4 into 6 square minus pi by 4 into 1 square into 2.5. What is 2.5? The vertical distance. The vertical distance is 2.5. You know how to find this distance. See, this angle is 45 degree. Okay, and this is 6 meter. And the half is 3 meter. Okay, so this distance is 6 minus 3. Sorry, one second. Okay, sorry. So this horizontal distance is 3 minus 0.5, which is 2.5. So horizontal distance is 2.5. The vertical distance will also be 2.5 because the angle is 45 degree. So when the angle is 45 degree, the horizontal distance and the vertical distance remain same. If you do like this horizontal distance is 2.5 and this vertical distance will also be 2.5. Okay, this is simple geometry. You can do this. You can do that. The volume is coming as 22.91 meter cube. Now we can find the weight of the material. Weight of the material in the hopper bottom. D. Weight of the material in the hopper bottom. Weight of the material in the hopper bottom. Okay. So volume into density. Volume of the hopper bottom, that is 22.91, into density of the material. Density of the material is 8. So this will give you weight of the material in the hopper bottom, that is 183 into 6 kilonewton, which is going vertically downwards. We also have to find the self weight of the hopper bottom. E, self weight of the hopper bottom. Self weight of the hopper bottom. So we need to find the mean diameter first. Mean diameter. Okay. 6 plus 1 divided by 2. 6 is the upper part, portion diameter. 1 meter is the downward portion diameter of the hopper bottom, plus thickness of the hopper bottom. We need to mean diameter. So since you are finding the effective mean diameter, you also have to consider thickness of the hopper bottom, and this is coming as 3.68 meters. Okay. So self weight self weight equal to C into thickness. C means circumferential distance. Circumferential distance of the mean diameter. So this is how the hopper bottom is. So we have considered the mean diameter. So we'll consider the circumferential of the mean diameter. Okay. Circumferential into thickness into A. What is A? This length. This inclined length. This inclined length is A. Okay. You can find that using trigonometry. Into density of the concrete. So pi into diameter. So what is circumferential distance? Circumferential distance equal to pi d. Pi into d is mean diameter 3.68 into thickness is 0.18 into a. The inclined distance is 3.54 into density of the concrete. So this is coming as 184.17 kilonewton, and which is vertically downward. Okay. Now you need to find the total weight. Total weight. So you need to no total weight means first weight load on hopper bottom, that is vertically downward. This will be plus 1731.80 minus 205.05, then plus 183.26, then plus 184.17. So total weight is coming as total weight is coming as, see, one thing you need to note here, the frictional force will be in minus because that is vertically upward and that is resisting the load. The frictional force is resisting the load. Okay. So total weight is coming as 1894.40 kilonewton. But we are interested in weight per meter. Weight per meter. Okay. So weight is 1894.40 per meter. per meter circumferential distance. Since we are dealing with the hopper bottom, we need to consider the mean diameter to find the circumferential distance. Pi into 3.68. So this is coming as 163.83 kilonewton. Okay. So we got the total weight of the hopper bottom, including the weight of the material, and that then we have converted the load into load per meter. Total into load per meter. And you see, if you take one hopper bottom, this load is acting vertically downward, whatever load you have calculated. And here you have direct tension. So there is relation between direct tension and the weight. Already we have seen this in case of our discussion in case of the design of bunker. We have seen this case. So T sine theta equal to W. Direct tension. See, hopper bottom is subjected to direct tension and it will also be subjected to hook tension. So we are required to design the hopper bottom for the direct tension and for the hook tension. Okay. So direct tension will be calculated by this formula. T equal to W divided by sine theta. W is 163.83 divided by sine 45. And the T is coming as 231.70 kilonewton per meter. Okay. You can find this is the direct tension that you got. Okay. From that you can find TU. Factored direct tension 1.5 into 231.70, and this is coming as 347.55 kilonewton. And you can find the area of the reinforcement, formula of area of reinforcement for the direct tension or for any tension for that matter. TU divided by 0.8 divided by 0.87 FY. 347.55 into 10 to the power 3 divided by 0.87 into 415. And this is coming as 962.62, which is greater than AST minimum. What is AST minimum? AST minimum is 180 mm square.